Right, here's a good question. What volume is phosphoric acid needed to react with sodium hydroxide? Okay, so we're reacting phosphoric acid with sodium hydroxide. Okay, so that'll produce double replacement reaction, so the hydrogen will go with the OH, so that'll be H and an OH, because hydrogen's positive, hydroxide's minus, and so the charge is balanced, so it's just HOH. Notice you don't bring along that 3 with you. You just balance what you have. Plus, and then the sodium goes with the phosphate. So sodium and phosphate. Now sodium's a 1 plus, phosphate is a 3 minus off the chart. And so I need 3 of these sodiums, so I need to put a 3 there. Okay, good. So I've determined what my products are. Now I just need to balance things. So what's off kilter? These hydrogens are off kilter. So there's 3 hydrogens here and only 1 here. Notice I'm treating OH as a group. So I'm calling it OH. I'm not separating it out to oxygen and hydrogen. So I have 3 hydrogens here and only 1 there, so I'll put a 3 there. But then that gives me 3 hydroxides too. And so over here I only have 1, so I need to put a 3 out here. Now I've got 3 hydroxides. But that gives me 3 sodiums, which I already have here. Here I have 1 phosphate. Here I have 1 phosphate. Everything's balanced. Okay, let me get rid of all my scribbling. Okay, that's a 3. Okay, so now that everything's balanced, 1 of these react with 3 of those to give 3 of those and 1 of those. That's my balanced chemical equation. Now let's write what we have. So we have, it says what volume, so that's what I'm looking for, of concentration is 0.20 moles per liter, is needed to react with 100 milliliters, that's volume. I'm going to convert that to liters, 0.100 liters. And the concentration is 0.10 moles per liter. So this is what I'm given, and this is what I'm asked. So this is my given side, my asked side. So I have solution stuff, so I'm starting here, Liquidsville, and I'm ending, also at Liquidsville. So I'm going to have 1 step to get to moles, 2 steps to get across the river, where I'll use these numbers right there. And the 3rd step will take from moles into solution. Okay, let's do those steps then. So step number 1, I'm going to take the concentration and volume of sodium hydroxide and convert it to moles of sodium hydroxide. Formula I use is this one. I need to solve for N, so I'll multiply both sides by V. That'll give me moles are equal to C times V. And the concentration is 0.10 moles per liter times the volume 0.100 liters. So liters cancel, and that'll give me 0.1 times 0.1, I think is 0.01, and some zeros after that, moles of sodium hydroxide. Okay, so now I've gone from there to here. So now I need to convert, step 2, my moles of sodium hydroxide. I need to convert that to moles of phosphoric acid. We won't go that high there. I don't know if you can see that or not, but okay. So to do that, it's the mole ratio. So I have 0.01 moles of sodium hydroxide multiplied by the ratio with my numbers here. So I'm going to put my 3 moles of sodium hydroxide on the bottom so that I can cancel them. And then I put my 1 mole of phosphoric acid on the top. So I just have to take that and divide it by 3. That's going to come out to 0.00, and then I think a bunch of 3s. moles of phosphoric acid. Let me just check my calculator to make sure I'm doing all those right. Okay, so I have 0.1 times 0.1, 0.01, yeah, that was right, and then divided by 3. Yeah, that's right, 0.00333, etc. Okay, last step. Let me go back up there. So I just went across the river here, so that's where I'm at. So my last step is to convert those into that. Okay. So last step is to take my moles, and I have a concentration of phosphoric acid, and figure out what the volume is. So my formula is C equals N over V. I'm solving for V, and so V is going to be equal to this cross, so 1 times N, which is just N, divided by the other number that's across from your V, which is C. So the moles, I just figured those out, 333, etc. Moles divided by the concentration right there, 0.20 moles per liter. Moles cancel, I'm winding up with volume, which is just excellent. So I take the number I had there before and I'm dividing it by 0.2. Go. So this gives me 0.01 and then a bunch of 6's. And that's liters. To do sig figs, it looks like I have 2 sig figs as my smallest there. And so this will be 0.017 liters. I guess if you wanted to write it as 17 milliliters, you could do that too. Right, hopefully that helps you with that question.